In this section, you will learn how to find the perimeter and area of a square when given the length of the diagonal, find the area of an irregular region by subtraction, find the ratio of areas of squares when given the ratio of their side lengths, and find the areas and perimeters of squares in which measures are given as variables. A square is a special case of a rectangle. Therefore, the theorems about rectangles also hold for squares. All four of the angles are right angles, the diagonals are congruent, and the diagonals bisect each other. Here are some additional facts about squares. In a square with side S, the diagonals of a square are perpendicular to each other. The diagonal divides the square into two congruent 45, 45, 90 triangles. The diagonal of a square D equals the square root of 2 times S, which is the side length. If the square has a side length S, the perimeter equals 4S. If the square has a side length S, the area is equal to S squared. Find the area of a square when the diagonal is known. Given the square with diagonal D, the area of the square S squared equals 1/2 D squared. Use the Pythagorean theorem to find the side length. A squared plus B squared equals C squared. Since the two legs equal S and the hypotenuse equals D, we have S squared plus S squared equals D squared. 2S squared equals D squared. S squared, which is the area, equals 1/2 times the diameter squared. Find the perimeter when the diagonal of a square is known. Look at the diagram below with sides length S and the diagonal D. The area, recall from the previous slide, S squared equals 1/2 D squared. Take the square root of both sides to find the side length S. S equals the square root of 2 over 2D. Obviously, that's after we take the square root and then rationalize the denominator. The perimeter equals 4S, which is 4 square root of 2 over the square root of 2 times D, which is 2 square root of 2 times D. Here's an example. A square has a diagonal that is 5 units long. What is the area and the perimeter? Find the area by using the formula S squared equals 1/2 D squared. S squared equals 1/2 times 5 squared. This becomes 25 over 2, or 12.5 square units. Take the square root of the area to find the side length S. The square root of 25 over 2 equals 5 square root of 2 over 2. To find the perimeter, multiply by 4, and you will get 10 square root of 2. Here's example 2. Look at the diagram below on the left. Figures A, B, C, D, and E, F, G, H are squares. Find the area of the shaded region. The square ABCD has a side length of 3. The four triangles are congruent by angle, side, angle. By the Pythagorean theorem, the hypotenuse is the square root of 5 because the legs are 1 and 2 units in length. The area of the larger square equals 3 squared, which is 9. The area of the smaller square equals the square root of 5 squared, which equals 5. Therefore, the area of the shaded region equals 9 minus 5, which is 4. Example 3. The area of a square is 25. Find its perimeter. Recall that A equals S squared, which gives us 25 equals S squared. Taking the square root of both sides gives us 5 equals S. Recall that S is the side length. The perimeter equals 4 times the side length, which is 4 times 5, which equals 20. Example 4. The perimeter of a square is 24. Find the area. First, we substitute into the perimeter formula. P equals 4S. This gives us 24 equals 4S. Solving for s gives us s equals 6. To find the area, we take the side length s and we square it. This gives us 6 squared, or 36. Example 5. A square has a side length s. In another square, the side length is 2s. What is the ratio of the area of the smaller square to the area of the larger square? The area of the smaller square equals s squared. The area of the larger square equals 2s times 2s, which is 4s squared. The ratio of the smaller to the larger square is s squared over 4s squared, which reduces to 1/4. Example 7. A square has an area of b units. Express the perimeter in terms of b. A equals s squared, which equals b. We take the square root of both sides. The square root of s squared is s. The square root of b is the square root of b. That's the side length, the square root of b. The perimeter is 4 times the side length, which is 4 square root of b. Here are some practice problems for you to try. Pause the video after each problem. Come back for the answer when you are done. Here's practice problem 1. The area of a square is 121 square units. Find the perimeter. The perimeter equals 44. First, find the side length. Since the area equals s squared equals 121, taking the square root of s squared equals 21 on both sides gives us s equals 11. That's the side length. We substitute into the perimeter formula. P equals 4s, which is 4 times 11, which is 44. Practice problem 2. The perimeter of a square is 32. Find the area. The answer to practice problem 2 is that the area equals 64 square units. First, find the side length. P equals 4s. We replace P with 32. 32 equals 4s. Dividing both sides by 4 gives s, the side length, equals 8. Now we substitute into the area formula. A equals s squared. That gives us A equals 8 squared, which is 64. Here's practice problem 3. Find the area of the shaded region. Note that E, F, G, and H are midpoints and that CG equals 2. The answer to practice problem 3 is 8. The easiest way to find the answer is to find the area of a shaded triangle and multiply by 4 since all the triangles are congruent. The area of a shaded triangle equals 1/2 base times height, which is 1/2 times 2 times 2, which is 2. Since there are 4 triangles, multiply by 4 and obtain the answer of 8 square units. Here's practice problem 4. Using the same figure in problem 3, find the perimeter of the smaller square. The perimeter equals 8 square root of 2. First, find the side length using the Pythagorean theorem, since the lengths of the square are hypotenuses of right triangles. A squared plus b squared equals c squared. Since both sides are 2, we have 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. 8 equals c squared. C, therefore, is the square root of 8. The square root of 8 can be factored into the square root of 4 times the square root of 2, which is 2 square root of 2. Find the perimeter. That's 4 times 2 square root of 2, which equals 8 square root of 2. Practice problem 5. Find the area of the smaller square used in problems 3 and 4. By the Pythagorean theorem, the side length of each side of the smaller square is 2 square root of 2. Substitute this value into the area formula. A equals S squared equals the quantity 2 square root of 2 squared. We multiply 2 square root of 2 times 2 square root of 2. It may be easier to rearrange the order in which you multiply and multiply 2 times 2 times the square root of 2 times the square root of 2. 2 times 2 equals 4, and the square root of 2 times the square root of 2 just equals 2. That gives us 4 times 2, which equals 8. Practice problem 6. Find the area of the shaded region lying between the two squares. The answer is x squared minus y squared. Recall that the area of the shaded region equals the area of the larger square minus the area of the smaller square. The area of the larger square equals x squared. The area of the smaller square equals y squared. Subtracting the two gives x squared minus y squared. Practice problem 7. One square has a side length of s. A second square has a side length of 3s. What is the ratio of the area of the smaller square to the area of the larger square? The area of the smaller square equals s squared. The area of the larger square equals 3s quantity squared, which is 3s times 3s, which equals 9s squared. The ratio of the areas of smaller to larger squares equals s squared over 9s squared, which equals 1 over 9. Practice problem 8. A square has a side length of 8. What is the diagonal? The answer is 8 square root of 2. The easiest way to find the answer is to use facts about special triangles. The diagonal of a square is the hypotenuse of a 45-45-90 triangle and is the square root of 2 times longer than the side of the square. Practice problem 9. A square has a diagonal of length 8. Find the area of the square, find the side length of the square, and find the perimeter of the square. Here are the answers to practice problem 9. The area equals 32. We use the formula that s squared equals 1/2 times the length of the diagonal squared. We're told the diagonal is 8. That's 1/2 times 8 squared, which is 64 over 2, which equals 32. The side length will be the square root of the area. Since the area is 32, we take the square root of 32. This factors into the square root of 16 times the square root of 2, which is 4 square root of 2. The perimeter will be 4 times the side length. That's 4 times the quantity 4 square root of 2, which is 16 square root of 2. Practice problem 10. A square has an area of q square units. Find an expression for the perimeter in terms of q. The perimeter equals 4 times the square root of q. First we find s. Remember that the area equals s squared, which is q. Taking the square root of both s squared and q gives us s equals the square root of q. The perimeter will equal 4 times the square root of q. Practice problem 11. A square has a diagonal of length d. Find the area of the square and find the perimeter of the square. The area equals s squared, which equals 1/2 d squared. The side length of the square is the square root of 1/2 d squared, which simplifies to the square root of 2 over 2d. The perimeter is 4 times that, which is 4 times the quantity square root of 2 over 2d, which is 2d times the square root of 2.